Hey guys, so in this video we're going to be going over naming alkenes and alkynes. We're going to build off of what we already learned for alkanes, just adding on some new information here. So, let me get my notes ready. So alkenes and alkynes are equal in priority. All right, let's write that down. Equal in priority. Some people teach that alkenes are higher in priority, but that's not correct. Although they are listed first in the parent name. We'll cover that. But they actually have the same priority. Okay. And they both have higher priority than alkanes and halogens. Okay. So the parent chain is not necessarily the longest chain anymore. It's going to be the longest chain that contains the most double and or triple bonds possible, okay? So the alkene parent chain is named by replacing ANE with ENE. And I know we talked about this in the first video as well. For an alkyne, well, you can kind of guess here. The alkyne parent chain is indicated by naming it instead of with an ANE, with an YNE. Okay? If there is more than one double or triple bond, the suffix is changed by adding a vowel, the vowel A, followed by the root name or the suffix describing how many, this should say suffix, I think. The suffix describing how many double or triple bonds are present. And of course, we still need to indicate how many we have by using di, tri, tetra, just like we did with the substituents, right? If we had 2 methyl substituents, we said, 2, 3 dimethyl, right? So then we'll go through practice with this. Okay? So the parent chain is numbered to give the double and triple bonds the lowest number possible. Okay, now we're going to do some practice problems, but if you have a double bond and a triple bond in a parent chain, then we are going to have to say "een" and "ein" somehow. So what we're going to do, for example, let's say we have this. Oops. So this would be 1, 2, 3, 4, 3, 5, 6. So that's 6. So this, okay, if this was all single bonds, we would say this is hexane. But remember, we've got double bond and we've got a triple bond. So it's not hexane, we're dropping the A and E. And if it was just a double bond, we would say ENE, but that's not true anymore because we also have a triple bond. So what we do is we can write ENE, but we're going to drop the last E, and we're going to fit in YNE. So if you have a chain that has double and triple bonds in it, it becomes an ene-ine. So not an alkene, and it's not an alkyne, it's an alkene-ine. It's weird, but that's how we do it. Now, the number indicating the position of the double or triple bond is listed before the parent root, or I guess suffix, before the suffix indicating that it's a double or triple bond. What do I mean by that? What I mean is, for example, this is the suffix that tells me that there's a double bond. Okay? And that's cool and all, that's great. But I need to know where this double bond is. Here, the double bond is between 3 and 4. Now what we do is we list the lower number, and we always number through double bonds and triple bonds. So I know that if a double bond is at carbon 3, that means it goes from 3 to 4. Okay, so we always list the lower number as the position of the double bond. So again, this tells me that I have a double bond, but how am I going to know where that double bond is? Well, usually the number will go right in front of that suffix. So I'm going to have to insert the number 3 right in there. And so that 3-ene tells me, oh, at carbon 3, you have a double bond. And then what about the triple bond? Well, here's the suffix for the triple bond, and here's our triple bond at carbon 1. And so again, we have to tell the position usually right in front of the suffix that describes it. So if I was to name this compound, it would be named hex 3-ene 1-ine, and that's it, you know. Of course, we can also indicate cis or trans, but we will talk about that in a later video. All right, so when numbering the parent chain, either the double bond or the triple bond could be assigned the lowest number because remember, they have the same priority. If the chain can be numbered either way and they both end up with the same number, then it's kind of like we're using the alphabetical rule again, where we give the first letter in the alphabet the lower number. And ene with an E comes before ine with a Y. So if they are numbered either way and they both end up with the same numbers, either way you number it, then you number the double bond with the lower number because ene comes before ine in the alphabet. That's how I remember it. It's not because double bonds have higher priority, because remember, that's not always true where they're going to have the same numbers. Okay, so let's do some examples, because remember, that's really how you get good at nomenclature. Examples, examples, examples. So write the IUPAC name for each of the following compounds. So here's my first compound, and I see that it has double bonds in it, and I know that double bonds have higher priority than single bonds, alkanes, and halogens. So I'm going to want to choose the longest possible chain with the most possible double bonds, okay? And so that is going to end up being this right here. All right, and we have a substituent. This is our substituent here. Oh, actually, now that I'm looking at it, let's back up. Let's consider this. I actually have 2 different parent chains I can choose. I can choose this yellow one, or this is hard to see, or I can choose the green one as my parent. Notice they both have the same number of double bonds and they both have the same number of carbons. But the green one has more substituents than the yellow one. Let's take a look at that. So the yellow one has just this substituent, okay? Now the green one though, oops, that's not what I wanted. The green one has a bromo as a substituent and a methyl as a substituent. So the green way has 2 substituents. So our parent is going to be that, including that carbon on top. Now how are we going to number it? Well, remember, the double bond has highest priority here, so we want to number it with the lowest possible numbers for the double bond. So this will be 1, 2, 3, 4, 5. And we've got a bromo and a methyl are the substituents. So let's say what our parent name is. Well, it would be pentane if this was all single bonds, but that's not what we've got. So we need to erase the suffix ane. Now here's the thing. We have, if we just had one double bond, so pretend that this one isn't there, then it would be pent 1-ene, like that. But because we have more than one double bond, we need to add the vowel A. Okay, I know it's weird. It's really to help so that there's not two consonants next to each other. So we've added the vowel A, and then we can list where they are. So we've got 1 and 3, and then we say dyene, because remember, we have to express how many double bonds we have. Well, we have 2 of them. One is at 1 and one is at 3. Okay, so that will be our parent name. And we have 2 substituents. We've got a bromo at 5, so 5 bromo. And we have a 4 methyl. Okay, so putting this in alphabetical order, it will be 5 bromo, 4 methyl, penta, 1, 3, diene. Now, the other thing is for the central double bond, we could add E and Z. Now, I have not, we haven't gone through E and Z yet. That's going to be in a slightly later video. So once you watch it, you can kind of come back and look at this little section. But this will end up being a Z. Okay, but we're going to talk about the stereochemistry in a later video. Okay. Okay, so let's highlight our parent chain. Remember, the parent chain has to include the most possible number of double bonds. In this case, it's just 1. Now, here's the thing. We can number this 2 different ways. We can number this parent chain in pink as 1, 2, 3, 4, 5, or we could number it in blue as 1, 2, 3, 4, 5. Both of these ways gives the double bond carbon number 1. Okay, so we have a substituent at 1, the double bond, right? But we also have the chlorine here is at number 1, and the methyl group is at number 2. If we look at the blue way, the double bond is at number 1, the methyl group is at number 1, and the chloro group is at number 2. So either way we number it, we will have the same numbering locations. The substituents will be on the same location either way, including the most important, which is the higher priority double bond. So how are we going to decide? Again, we're going to fall back on the alphabetical rule. So what comes first in the alphabet, chloro or metho? Well, the answer is chloro, so we want to give the chlorine the lower possible number. So we are going to use the pink system, not the blue system. So my parent name for this is going to be cyclo, because remember, it's a ring. Cyclo, now this would be cyclopentane if it was all single bonds, but remember we have a double bond there, so it's not cyclopentane, it's cyclopentene. Okay? Now, because this is a ring, you don't necessarily have to say that the double bond is on carbon number 1, because you're supposed to give double bonds the lowest possible number, and that in a ring will be 1. But I'm going to go ahead and add it because some people will write it in. So cyclopent1ene, although you don't have to because it's implied that it's at the number 1 position. We have a 1 chloro and we have a 2 methyl. So putting this in alphabetical order, 1 chloro, 2 methyl, cyclo, pent, 1 ene. Alrighty, so that's how you would name that. So this next one, oh goodness, this looks like lots of fun. Okay, so let's pick the parent chain. Remember the parent chain? We want to have the longest chain possible, but it needs to include as many double and or triple bonds as possible. And so for me, it doesn't matter if I go, it doesn't matter if I go up or if I go down, because you can see both of those are actually the same group. So I'm just going to go down because it's easier for me. All right, so let's circle our substituents here. We got a substituent there. Now, how are we going to number this? Well, remember we want to give the lowest possible numbers. So let's try both ways. Let's say we can go 1, 2, 3, 4, 5, 6, 7, 8. So if we use the pink system, we've got a triple bond at 1, a double bond at 4, a substituent at 6, and a double bond at 7. Okay. And remember, we do want to focus on double and triple bonds because we want to give them the lowest number. So I'll underline any double or triple bonds. So 1, 4, and 7 are double or triple bonds. So blue, we could do 1, 2, 3, 4, 5, 6, 7, 8. So blue would be 1, 3, 4, and 7, where 1, 4, and 7 are the double and or triple bonds. So notice the double and triple bonds have the same number either way you go. The only difference is this substituent here has a lower number in the blue system than in the pink system. So we're going to go with the blue system. So we've got 8 carbons. Well, this is going to be interesting naming this one. So this is going to be oct. Now it's not going to be octane. It's going to be 1, 4. Oops, nope. Hold on. That's okay. Okay, so oct, but remember we have multiple double bonds here. So remember we have to add the vowel. So it's going to be octa, 1, 4, diene. But remember we also have a triple bond, so we're not going to finish with an E. We're going to have diene, and then that's at number 7, 7, ine. So that is our parent. Now we have this substituent. Now this brings me to 2 kind of common substituents. If you see 2 carbons and they're connected by a double bond like this, this is called a vinyl, vinyl substituent, right? That's the common name for this. You could also call this would be called an ethyl, let me write it out, I think it would be an ethynyl. Actually, now that I think about it, I don't even know the official way of naming this. I'm going to have to look it up in a second. So that's a vinyl substituent. If you have 3 carbons like this, then it's called, and the double bond is in the last position, then it's called an allyl substituent, okay? And that's because this carbon is what we call the allylic position, which is the carbon, any carbon that is 1 carbon away from a double bond. Okay, so here's a double bonded carbon and it's 1 away. So, so this is actually a vinyl substituent. So this will be 3 vinyl octa 1,4 diene 7-ine, ine, and that's it. So 3 vinyl oct 1,4 diene 7-ine. It's a lot of work. And so that is it for this video.